Hi, this is Alan Gleeson. Please subscribe to the ADSR YouTube channel for further tutorials. In this video, we will discuss Spectrum Analysers, how to read them and modify them to display what we need to see. For those not familiar with using such a tool, this is a perfect introduction. Using the free plugin Span from Voxengo, I will demystify the various controls contained within, and similar controls are found on all analyzers. Whether you're a beginner or a pro, having a visual aid that performs real-time frequency analysis to help you in the music production process saves time in problem solving and helps you produce better sounding mixes and masters. All Spectrum Analysers are based on an FFT or fast Fourier transform analysis. This splits the signal up into its sine wave components and allows us to view the frequencies and harmonic content of sounds, instruments and mixes. In the graph, the x-axis represents frequency and the y-axis represents volume measured in decibels. When using an FFT-based analyzer, there is always a compromise between frequency and timing resolution. The more accurate the frequency resolution, the poorer the timing resolution. In practice, we nearly always want better frequency resolution, as it is advantageous to be able to pick out individual frequencies. So to vary the settings in our analyzer, we open up the edit window by clicking on this icon in the top right corner. The window that opens up contains all the settings that we need to adjust how the graph displays information and responds to the incoming signal. The FFT or block size sets the number of samples that are sampled in each measurement. Higher settings produce better frequency resolution at the expense of timing resolution. I find in most cases a block size of 16,384 gives the best balance between frequency and timing resolution. But let's look at this in action. So I'll move the mode editor window to the side and we'll just concentrate on our graph. So we'll start off with lower block size, say 256, and I'll play our mix. So as we can see here, we're getting a very averaged kind of response in the result in the graph. As I increase the block size, we can see more detail coming into the graph that's been produced. But what you will notice, as I mentioned, the higher the settings that you use, the poorer the timing resolution in the results that we're getting. So if I put it up to the highest setting, this is giving us the most accurate frequency resolution, but you can see as a result the timing is suffering. We can affect this and get a better result by tweaking our overlap time here. So when it's set all the way down, you can see that the result that we're getting is quite stuttered. As we start to increase the overlap time, the result becomes less stuttered. This does also affect the timing resolution, but it gives us a better response than stuttering. So over in our type section, we've got RT average selected, which engages real-time spectrum averaging analysis. This is probably the most useful setting, and it averages the spectrum over a specified period specified by the average time set here. So this parameter in conjunction with the overlap can help us get a smoother response when we're using higher block sizes. Other type settings that we have is max, which is a cumulative real-time peak value. So when I play the mix, it's going to log all the peak values or the highest values in the mix and accumulate that over time. As I said, most time the RT average is the setting that's most useful. And I put the block size back to 16,384. And because we've tweaked our overlap time and our average time, we're getting pretty smooth results here. The controls along the bottom here set our display range. So we can set the low and high frequency range and the low and the high volume range that we're going to measure. So by default, you might measure say something from say 20 Hertz to 20 kilohertz, and a low range to set depending on the material that you're working at. But I would find something around -80 up until around 0 is useful. The next control here, by default when you load this plugin, is set to 4.5. So this control is a bit unusual and you don't always get this in Spectrum Analysers. And what it does, it allows you to change the slope of the curve that's been produced. So if I switch over to another track that's just playing white noise, and I'll start playback using the default setting. So we're producing white noise here. The slope that we're getting should be pretty horizontal, but the effect that we're getting here is raising as it gets up to the higher frequencies. And the reason that they include this is if we go back to our music, is that in Spectrum Analysers, the high frequency content tends to have less energy than the lower frequency content, and by adjusting the slope, it gives us a more even display. But because I'm used to using other frequency analyzers, I want this to respond the same way. So I tend to put it to 0, but the preference is up to you. So this is a typical display where you tend to have more energy in the low end and less in the high end. We switch over to our white noise again. You can see that we're now getting a much more linear response. As well as being able to adjust the display here, we can also adjust it in our main window. So when I'm playing back my audio, if there's a particular area that I want to focus in, I can use these sliders at the bottom to scroll and move into a particular area that I want to address. So there's a resonant issue that comes up every now and then, and I can read it as being this point here. Jumping up there. If I wanted to focus in more on the volume, I could use my controls here on the right hand side. If I wanted to freeze the graph at that particular point to allow me to give a better reading of what's going on, I can click on the hold button here in the top left corner. So now I can stop the audio, and when I roll around here with my mouse, wherever I stop, it gives a reading of the frequency, the pitch, and the volume for that particular point. If I thought that this point here was too resonant, when I roll over it, in the top left corner there, I can see that it's 879 Hertz. So I could go to my EQ on this track. I can open up my EQ and type in a particular frequency, 879 Hertz. And now I could adjust my Q and my gain and maybe solve that resonant issue that I was actually having there. There's other functionality within the plugin to help you view and calculate frequencies that you might want to alter in your EQ or processing devices. So I'm going to reset by double clicking on this icon in the bottom corner. And I'll show you another method of zooming in and out. When you're viewing your graph, if you hold down the Alt key and then drag with the mouse, you can see it's creating a window there with zoom in written in it. So when I release the mouse button, it now zooms in. If I want to return to my full view again, I just hold down Alt or the Option key and I double click and it goes back to my previous zoom. What I can also do when I've zoomed in, if say I wanted to address this particular frequency here, if I hold down my Control key and click there, a little text has appeared there saying the frequency has been copied to the clipboard. So that now I could go back to my EQ, select my frequency area, and now do a Command and V and paste that particular frequency in. And I can quickly adjust my Q and my gain to affect that frequency area. So to zoom fully out again, I hold down Alt or Option and I double click and it takes me back to my full screen. Take it out of hold and it starts the real-time analysis again. So because this is a full mix, it could be quite complicated to read exactly what's going on. I'll go over to another mix that I have here that's more synthetic and has less drums and information going on, and we can see it's easier to pick out the frequencies that are going on within it. As the filter is changing, I can see the various areas that it's emphasizing. And because there's less going on the low end, I can clearly see the harmonics, so that if I did want to address any of these when I roll over them, I can see in the top left corner the frequencies of those particular harmonics, so I can go to my EQ and attenuate or boost those particular frequencies. If I wanted to isolate a particular frequency range, say go back to my other mix, say if I was having difficulty hearing where the kick drum was, by holding down the Command key and clicking where the crosshair is, it now solos that particular frequency range. So the different areas, that's where the sub is in the kick. And if I scroll up more, you can see that that's probably maybe the first harmonic in the sound. A bit more punch to it there. So that if I wanted to add more sub, I could figure out the exact range that I want to go, and then I'll release the command key and have another look, or maybe I'll even zoom in there and I'll pick out where the kick is hitting. So now I would say that that's where the kick is hitting there, and it's telling me that's 46.7. What I want to do, I could hold down Control and click there, and I'll copy that frequency to the clipboard, and I could paste that into my EQ plugin. If you set up the device in a particular way and you'd like to keep that setting, if you go back into your editor, in the top left corner you've got a presets section here. So when I click this, it opens up. I could click on plus and type in, say, user 1 and click on OK. And I'll just close this again. If I wanted to set it to address a different frequency range, I could come in here and set it to, say, the lowest value that I can set for this, which is 2000 Hertz. And say I might want to have, say, I don't want to measure down to 20 Hertz, I might want to start at, say, 200 Hertz. And then I'll save that preset, call it as mid-range. Click on OK. And now when I go back to my main window, where it says mode here in the top right corner, I'll see that now I have my mid-range preset. So when I select that, it goes from 200 to 2K. When I go back to my default, it's measuring from 20 to 20K. In the lower section here, we have an RMS reading, which is measuring the average loudness. And over in this section here, we've got a maximum peak value. And this peak is measuring digital full scale, or dBFS. We've got a correlation meter here, which is measuring phase. So when you're monitoring a mix or a sound, as long as it doesn't go below 0 here, it will be in phase. Then we have our master meter on the right hand side, and you can set different scales for this also in the metering section here. You can reset the values. So that's all the main functionality contained within this Spectrum Analyzer. As I mentioned, these are incredibly useful tools for giving us a visual aid to see what's going on with the frequency content of our mixes, instruments and sounds. As this is a free plugin, you can download it and start using it straight away. This has been Alan Gleeson for ADSR. Please subscribe to the ADSR YouTube channel for further tutorials.